access to it. Jordan, Jeremy, close your laptops. Sorry, Jacob, close your laptops. Where is it? Do you have anything you can write on? Then get some paper from somebody. Write notes. Close your laptop. All right. Okay, we're going from here, from 1G, which is finding the equation of our lines. Okay, that's our focus for today. And again, if you haven't finished the previous chapters, you'll have time to complete it. But if you can at least get up to this chapter, I think we'll be doing all right. Okay, we'll be up to date with everything. Okay, so let's get straight into it. Linear relations, chapter 1G, finding our equations, right? That's the focus for today. Finding equations of your lines. Now, before we get straight into it, actually, well, just go through our learning intentions. So the idea behind today, and the good thing is, all of this is something that you've already done a little bit of already if you've done the previous two chapters. So if you've done 1D and 1F, this should make sense. So if you haven't done 1D and 1F, I would highly recommend you do that before you start doing this. But listen to the tutorial for this one so you know what you need to do. But what we need to be able to do today for this topic is find the equation. Okay, that's the main thing. Okay, find the equation. Every line that you work with is going to have some sort of equation that you need to find for. And you can do that by using any 2 points, okay? Remember when we draw our lines on our graph, you only need 2 points. Okay, it's the same principle when finding an equation. You only need 2 points for this, okay? Now, we need to be able to find the equation, but to do that, you need to find the gradient. So calculating the gradient, we'll find the y-intercept. Everyone knows what that is. So it's where the line hits the y-axis. Calculate the y-intercept if you have 2 points. So again, 2 points is very, very important when we're working with graphs like this. And then create the equation is obviously the main thing. Okay. Now, let's go. I'm going to quickly recap on a couple of things. So remember, all of our formulas should look like this. Y equals mx plus c. Each letter represents something. We know what x and y represents. X and y represents the x to this line and the y-axis, which is, so the x-axis, which is this line, and the y-axis, which is that line. Okay, but m and c represent something else. M is your gradient. So remember that. And C, with the symbol in the front, is your y-intercept. So don't forget these principles. You need to know the gradient and the y-intercept for any formula. Those are 2 things you need to find. Okay, let's say you have this formula here. I'm going to make one up. Y equals, let's go 2x minus 3. Okay, 2x minus 3. Now, can anyone tell me what is the gradient and y-intercept for this? Okay, good. Y-intercept. We use another color. So the y-intercept is -3. And what's the gradient, guys? Good. So the gradient is 2. Not the x, yeah, just the number that's next to the x. But because it's a whole number, if we do rise over run, what do? Put it over 1. Okay, so the gradient is 2 over 1. Now, let's graph this. Okay, you got your Cartesian plane, put your x-axis and your y-axis there. Okay, so I'll label that for you. That's your x, that's your y. All right, and let's graph this. Now, for simplicity's sake, actually, I'll write it for you. I'm going to put in the number lines so you can see what the numbers are. Okay, so that's 1, 2, 3, 4. And over this way, it's going to be -1, -2, -3, -4. On my y-axis, again, you got 1, 2, 3, 4. Making sure, didn't do a good job of it, but your lines are equally spaced out. Okay, and on your y-axis, on the negative side, you've got -1, -2, -3, and a -4. Okay, you don't have to do this, okay, but I'm doing it for your sake so you know what we're doing. and you can actually see how we draw the graph. So let's do the y-intercept. According to this, the y-intercept is -3. So on my y-axis, where is -3? Anyone know? Where is it? Tell me. Where is it, Francis? On the bottom. Good. So we start there. Remember, you only need 2 dots. There's my first dot, or 2 points to draw your line. The gradient is 2/1. It is a positive number. So which way are we going if it's positive? We go up. Okay. So according to this, we're going up 2 spots and then 1 to the right. So let's go up 2 spots. 1, 2, and then we go to the right 1 spot. So there is my second point right there. All I need to do now is draw the line. Oops. There's my line. Now what this is a representation of our formula y equals 2x plus 3, where the y-intercept, as you can see, is -3, and the gradient is 2, based on our gradient here, 2/1. And again, if you count from one point to the other, it's 2 for the rise, 1 for the run. Okay, so 2/1. 2 for the rise, 1 for the run. Okay, so it's 2/1. That's how we get 2/1 for the gradient. All right. Let's relate this back then to what it is we're learning today. So remember our equations, okay, always have to look like this. Y equals mx plus c. In this formula, y-intercept is c. Okay, remember that. And I don't know why we have this, but the m is the gradient, okay? And you've also got some other things here. We've also got stuff about vertical lines, which we did learn about, I believe, yesterday. Well, we'll quickly recap on that. All right, so let's have a look at this. Let's go to these questions here. So I can see here for this graph, or these 2 graphs, I've got 2 special lines. Yes? Okay. All right, you've got 2 special lines here that we need to find the formula for. I can see the first one here is a horizontal line, just going that way. Whenever you see a line that's like this, the formula is just going to be y equals, where does it intercept the y-axis? 2, so it's literally just y equals 2. That's it, okay? What about this line here? Okay, I can see that it hits the x-axis. Okay, if it hits the x-axis, it's going to be x equals. Let's see. Thomas, what do you think this formula would be? X equals what? Where does it hit the x-axis? Easy. Okay, so if your line is just vertical, it's an x equals. If it's horizontal like that, it's just y equals. Okay, really easy. That's all we're doing for these lines. All right, let's move on. Now, when it comes to finding the gradient, okay, we've done a little bit of this, understanding the rise and the run. Okay, what we're doing is essentially measuring or giving a numerical value to how slopey the line is. So the bigger the slope, the bigger the gradient. The more flat the line is, the lower the gradient. Or if you have a flat line like that, that means your gradient is 0. Okay? And obviously, if it's going up like that, it's positive. If it's going down, it's negative. Okay? All right, so the rise over run is what we use. But how do we use that to find the gradient? So remember, you need to have 2 points. You always got to have 2 points when you're working with this. And then from the first point, as you can see on the left, work to the rise and run. So I will explain what that means if we look at this. If you look at this graph here, you can go this way or you could go the other way, which is go up then right. And I'll go up then right because it's probably a bit easier. But in terms of the rise over run, I can see that this has a rise of 6. Why is it 6? Well, the space between 3, so this is a value of 3, and this is 9. How many spaces is that? 6, okay? That's why it's a value of 6 for the rise. So 1, 2, 3, 4, 5, 6. So you've got 6 for the rise. And then from this point, so from the 2 all the way to 6, so that's 2 and that's 6. What's the space there? You've got 1, 2, 3, 4. That's why the run is 4. I could go the other way as well and say that the run is 1, 2, 3, 4, okay? and then the rise is 1, 2, 3, 4, 5, 6. That's why it's rise over run. Oh, that's why the run and the rise are whatever the values are there. Okay, but that's fine. But the way that we'll assess you is a little bit different. Okay, we're going to be using formulas for this. Okay, so make sure you're following along so you can figure out how to use the formula to find the gradient. Okay, remember, it's always about using 2 points on the graph. So you've got to find 2 points. And the thing about the 2 points, actually, can anyone tell me what's interesting about the 2 points on the graph? Where are they located? Yes. On different sides of the y-axis? Yes, that's a good evaluation. But there's one more thing I'm looking for with regards to the line. Where are they on the line? Well, they're on the line, aren't they? So the 2 points have to be on the line. You can't pick a random point here and like a random point here, for example, because they're not on the line. Always pick 2 points that are exactly on the line. So these points are on the line, okay? And be mindful, when we talk about points, okay, we're talking about the coordinates. So if you can see the coordinate, that's x and that's y. That's x and that's y. Notice how we've labeled them just x1, y1, and then x2, y2. Okay, label it like that. You've got 2 points, call them x1 and y1, x2 and y2. Okay, so the first point I can see is negative 4, 4. So that's this point right there, because it's negative 4 and then up to the 4 there. Okay, negative 4, 4. And the other point is 2 and then 1, which is there. Okay, those are my 2 points. Cool. Now, you've probably seen this formula before, but you're going to be referring to it a lot. So I would recommend that you maybe circle it or highlight it. This is the gradient formula. Okay, you're going to be using it often. Gradient formula. You'll be using it to find any sort of gradient with any gradient question. Hey, Mr. White. Sure. All right, so there is my gradient formula. How do I use it? Well, look at it. Okay, y2 minus y1 divided by x2 minus x1. So where do we get y2, y1, x2, x1 and all that? Well, again, that's from the 2 points. Okay, so all you're doing is you're changing, okay, the x and y values to whatever the x and y values are here. So let's do that. There's space for you provided there, so make sure you look at this formula. All right. So you've got your formula. Cool, cool, cool. Let's substitute it. So y2 minus y1. y2 is there, which is 1. So you're going to put in your formula 1, take away y1, which is 4. Okay, it's y2 and y1. So I'm looking at y2, which is 1, and then 4, which is y1. And then divided by, so if you want, put it in brackets, x2, okay, which is 2. So 2. Take away x1, which is negative 4. Now watch out for that negative. Minus, what did I say? Minus 4. Okay, when you put the double negative in your calculator, it's going to become a positive. Okay, so I can put that for now here. Actually, let me just solve it. So 1 take away 4 is negative 3. And then 2 plus minus negative 4 will be 2 plus 4, which equals 6. You can check your calculator. Oh, and if I simplify it, let me just simplify that. It'll be negative 1 over 2. So put it in your calculator. Okay, when you do that, bracket 1 take away 4, close the bracket. Oops. And then put it on the bottom. 2 take away negative 4. Again, if you put 2 negatives together, it becomes a plus. So if you're not sure, just use your calculator for this. Okay, all you're doing again is you're substituting x1, y1, x2, y2 into that graph. Okay, into this. All right, you're working. Cool, cool, cool. Any questions so far? So there's my gradient. Any questions? Not hard, yeah. Gradient's not hard to do. All right, so there's our first part, my gradient. Now remember, actually I don't know if there's anything else here. Actually, that's all we need to know for now. Gradient, easy. Yeah, do you want to try another one? Maybe I'll give you another one. Let's do another easy one here. I'll give you 2 points. Let's go 2, 7. And then we'll go -0, -4, for example. Okay, I just made those up. I don't know if it's going to work. It should work. Okay, and using our formula. So, before I do that, remember label it x1, y1, x2, y2. Always label them. Okay, let's put it in our formula. So remember my formula is y2 minus y1 divided by x2 minus x1. Let's call it the gradient. Okay, substitute it into your formula. So I can see here it's going to be y2, which is negative 4. So negative 4, take away y1, which is 7, divided by x2, which is 0, take away 2. Okay, and then substitute it. So you now have negative 11 over negative 2. If you put that in your calculator as well, what's going to happen is it's going to be 11 over 2. There's your gradient. Okay, nice and easy. Okay, put it in your calculator if you want. So negative 4 minus 7, 0 minus 2. Right, 11 over 2. Easy. What's your question, Izzy? Okay, because, have a look, there's two negatives there, that's why. Negative 11. Whenever you divide or multiply negatives together, it always becomes a positive. Okay, negative with negative equals positive. Okay, that's how we use the gradient formula. Okay, so make sure you're comfortable with it. Now, the other thing we need to learn is also now finding the formula and doing it all together. Okay, putting everything together. All right. Cool. All right. So from this, we need to find the gradient, find the y-intercept, and then give us the rule in the y equals mx plus c form. Okay, so part A, let's look at the gradient. Let's find the gradient. The 2 points we're using. Anyone want to tell me what the 2 points are? What are the 2 coordinates or 2 points? Jamie, can you tell me what they are?
3, 7.
Good. So you got 3, 7, and then 0, 1. It actually doesn't matter which one you use first or second, as long as you've labeled them properly as x1, y1, x2, y2, so that you use the formula properly. Okay, let's find the gradient. Okay, I'm going to put this here. Remember, the gradient formula is y2 take away y1. Okay, you can put it in brackets. Divided by x2 take away x1. Okay, that's the formula that we've learned just then. So let's put that in our calculator, or let's substitute it first. So y2 is 1, y1 is 7, divided by x2, which is 0, take away x1, which is 3. Okay, you can probably work that out, but that's going to be negative 6 over negative 3. Okay, if you put it in your calculator, it will simplify it to 2. Okay, and I'll show you. Again, if you're really confused about how to do this, just chuck it in your calculator as you see. So it's going to be 1 minus 7, close your bracket, and then 0 take away 3. Okay, which equals 2. What do you mean by the other way around? Yeah, so did you do this? You actually used x2, y2, x1, y1. Yeah, that's fine. That's why I mean, it doesn't matter if you use it the other way. As long as you've labeled them correctly like that and you put it in the right spot, you should still get the same gradient. Okay, that's it doesn't matter. Okay, because what matters is you put the right ones in the right spots. Okay, it doesn't really matter. If I use this as x1, y1, and then this is my x2, y2, it still gives you the same answer. Okay, so good observation there. All right, so that's the first part. Part B, state the y-intercept. Okay, what is the y-intercept? So the y-intercept is where the line hits the y-axis. Anyone want to tell me what the y-intercept is?
1.
Good, so the y-intercept is 1. Now let's put it in our formula. Okay, so this is my y-intercept. That's my gradient right there in blue. Okay, so in my formula, state it in y equals mx plus c form. Okay, so y equals mx plus c. There's only 2 things you're changing. You're changing m and you're changing c. C, remember, is the y-intercept. M, remember, represents the gradient. So your formula should be 2x plus 1. Okay, because my gradient is 2, that's what I change here. Maybe I'll change this to, and the y-intercept is 1, which is there. Okay, those are two things you're changing, just the gradient and the y-intercept in the formula. Does that make sense? Not hard, not hard. So you're looking for a gradient, y-intercept, that's it. Let's try, okay, we're nearly done. So let's just do this one and then we'll start working. Now we're gonna find the gradient and the y-intercept, but with this, okay, being the issue is we don't know what the y-intercept is there. So let's figure out what it is. Actually, let me pause real quick. Points, I've got 2. I have 4, 7, and then 8, 2. 2 points. All right, first question is, I need to find the gradient. So question A, or part A of that question. Remember my, label it x1, y1, x2, y2. Gradient formula is y2 take away y1, if you want, put it in brackets, divided by x2 take away x1. Okay, substitute that into your formula. So y2 is 2, y1 is 7, so 2 take away 7, divided by 8 take away 4. So this should be negative 5 over 4. You can double check on your calculator. Yeah, put it in there. 2 take away 7 divided by 8 take away 4. Yeah, there it is. Okay, there's my gradient. Easy. So what you need to do now is when you get a question like this, yeah, you need to write down your formula so far. Remember, it should look like this. Y equals, use another color, y equals mx plus c. Now, in our formula, what do we know so far? We know m. Okay, so let's change m so far to negative 5 over 4. Okay, that's what we know at the moment. Now, in this question for part B, it's asking us to find, substitute the gradient, which we just did, into the coordinate and use one of the coordinates in the formula, so one of these, to find out what C is. So all you have to do now is looking at that formula, just pick one of these two coordinates, any one of them, so either x1, y1, or x2, y2, and change that into the x and the y here to figure out, because you're trying to look for C. So, Jamie, which points do you want to use? I want to ask you.
4.
Cool, let's go 4 and 7. All right, so change 4 and 7 into the x and y here to find out what C is. So let's change y, it's going to become 7 equals negative 5 over 4. It should be in purple, sorry. Negative 5 over 4 times, and then what's x going to be? 4, okay? Right there. Plus C. Okay, so now what we're doing here, you guys have done this before, you're just solving for C. You're going to isolate C. Okay, isolate C in this case. So I'm going to put an arrow here so we can find out what C is. All right, let's equate this. So you got so far you got 7 equals negative 5 over 4 times 4. Does anyone know what that is? Negative 5 over 4 times 4.
5.
Good. You can chuck it in your calculator. Let's double check that Tina is correct. So negative 5 over 4 times 4. Negative 5. Okay, so you have so far negative 5 plus C. Okay, what's my next step here, guys?
Okay.
Jonathan, what's my next step? If I'm trying to find C, what do I need to move?
Negative 5.
Good. Okay, if I bring it here, what happens? Turns to a plus 5. Oops. So what's 7 plus 5? 12. That means C equals 12. So, going back to our formula of y equals, so far we know that it's negative 5 over 4x. My y-intercept is going to be 12. There's my formula. Easy. Done. Okay, let's do one more. But I don't know if you have space in your books there. Oops, sorry. We'll do one more. Maybe for this one that we're going to do one more of. Let's put this in our bound reference. Okay, this is going to be a good one to use then. Okay, let's do one more. We'll put it in our bound reference. Finish copying this. Well, let's do one more. And we'll put it in our bound reference. All right, one more and then put in bound reference. Yes.
5 and then you add it to the 7.
Mm-hmm.
If it was a positive 5, would you take it away?
Yes, it would be minus. Good. So it's the opposite. That's what inverse is all about. Okay, so you get your bound references out, or copy this on a piece of paper so we can do it. Let's use, I'm going to use a question from here. No. Copy this in your bound reference. I want to use this one. Okay, so if you're up to it, please copy this one in your bound reference, okay? Oh, sorry. And let's call it finding equation of line. Okay. Copy that one in there. I want you to have one of these in your bound reference. It's going to be good to have. Of line, sorry. Okay, copy this one in your bound reference. Be a good one. You guys are doing really good, by the way. I'm very impressed with the first part. You're keeping track. This second part is just adding one extra step to it, but that's really it. If you can do most of it, I'm sure you'll be all right. Okay, can I move on to this one? Okay. Slower than my grandma. All right, let me pause this. There's two parts to this. Yeah, remember your equation. If you're looking for the equation, it has to look like this. Y equals, let me put it here. Y equals mx plus c. Okay, that's what we're looking for. There's two things, the gradient and the y-intercept. Two things we're looking for. Now for this question, let's write down the two coordinates we're going to use. Okay, what are the two coordinates? Anyone want to tell me? Anyone want to know? What's the two coordinates? Good. And then 1, -5. Okay, let's label them. x1, y1, x2, y2. Okay, you don't have to do this, but you can put a line down the middle just so you can find. Actually, no, that's just not good. I don't want to confuse you guys. First thing, let's find the gradient. Okay. So the gradient. You don't have to write the formula, but for your sake, I will do it. y2 minus y1. Put it in brackets if you like, divided by x2 minus x1. Okay. All right, so therefore, put the numbers in your formula. Let me change the color. y2 is -5. y1 is 1. So for -5 minus 1. x2 is 1. x1 is -1. So be mindful it's minus -1 when you put it in your calc. Okay, you don't have to do this, but if you really are not confident about your fractions and whatnot, by all means, put it in your calculator so you can get it right. Okay, -3. So -3 is the gradient. Okay, so far, and what I'm going to do here in my formula is this is what we have. Remember, this is the final answer, but it's incomplete. Y equals, so far you have -3x Okay. Plus, and now we're looking for the gradient. Okay, we don't know what the gradient, which is c. Okay, but I'll work that out here. So far, what we have is, and let's rewrite the formula. Let's go red. Y equals, no, actually, let's go blue. This is what we have so far. Okay, so now we're going to look for y-intercept, which is this guy. So this is what we have so far. And remember what we did last time. All we did is we're just picking one of these, either these coordinates or these ones, and just changing x and y in there. And that's all you're doing. Anyone want to pick what coordinate do you want to use? Okay, let's do that one. Let's do this one. This is what you're going to pick, Ruby? Yeah, okay, cool. Let's go with this one. I can see that y is -5, so let's change y to this y here, which is -5. So you got -5 equals -3 times, and then the x is going to be 1 plus c. Okay, so here we've got, we need to calculate and figure out what c is. All right, so -5 equals, what's -3 times 1? -3 plus c, okay? And as Jonathan showed us before, we're trying to isolate c. So what am I going to move to find out what c is? -3. Yeah, this is a -3. Here becomes +3. Therefore, the y-intercept c, what's -5 plus 3? If you're not good, if you're not sure, use that calculator. C is -2. So in my final formula, c is -2. There it is. Easy. Okay, if you have this in your bound reference and you can do this easily, I think you'll be all right. Yeah? Yeah? No, yeah? Yeah? I'll stop actually. Any questions? Any questions? Any questions? All right. Let's see. I don't know if I'll leave that there, sorry. All right. This is the annoying thing. A lot of you guys freak out when you see worded questions, but it's exactly the same thing. Okay, it's not that bad. You just got to look at, in year 11, this is what they do as well. They give you the information, and then you're asked to do 3 things. What's the rule? Okay. What's the y-intercept, which is what it's asking, and then make a prediction. Okay. So question 1 is find the rule linking the amount of investment and the number of years. Right, if you look at the question, it says this guy invests money in an account and he gives a constant rate over time. So that means it's going up by the same amount. He hopes to buy a boat when the investment reaches 20,000. Okay, after 3 years, the amount is, okay, here's some important information. 3 years, the amount is 16,500. Okay, that's a clue. And then after 6 years, the amount is 18,000. Okay. Find a rule for linking the investment A and time. Okay, it's the same as find the rule for y equals mx plus c. The only thing they're changing here, okay, is A. Instead of A, we're going to use money. Okay, instead of y, we're going to use A, which is confusing, I know, but bear with me. And instead of m, we're going to use time. Okay, for those ones. But it's fine. Let's just stick to this for now. So we're looking for the equation here. What do we need to use? What do we need to have to find an equation? Does anyone remember? We need to have 2 what? 2 points. Can you guys see the 2 points that are highlighted there? Okay, let's list them out. The first one is 3, 16, 500. What's the second coordinate or second point? 6, 18,000. That's it. You guys already know what to do from here. Okay, you've done it so many times. So let's put it in our formula for the gradient. All right, so the gradient is going to be, remember, y2, I'll put the formula here for you. y2 minus y1 divided by x2 minus x1. And you can label it, yeah? x1, y1, x2, y2. All right, so for the gradient, y2, take away y1, so that should be 18,000 take away, oops, take away 1,000 or 16,500. Okay, that's the first one. Second one, okay, is going to be y x2 minus x1. So that's going to be 6 take away 3, which is what x1 is there. Okay, work it out in your calculator. Mr. Toddy is not smart enough for this, so I will put this in the calculator. 18,000, oh yes, 18,000 take away 16,500 over, ooh, okay, see what happened there? Make sure you watch out how you type it in your calculator. I'll type it in again. Let's do it like this, 18,000. Take away 16,500. And on the bottom, 6 take away 3 equals 500. So the gradient, actually, yeah, I'll leave it there. Actually, I'll put, yeah, okay. That's my gradient, 500. Okay, 500. All right, and then the next part, okay, is going to be the y-intercept. Yeah, so far, what do we have for our formula? Y equals, remember, m is the gradient, so 500x plus c. Okay, now I need to find c. Okay, so use any of the 2 points that we have here and substitute it into this formula. Anyone want to pick one for me? Cool. All right, let's do 18,000. So we're going to use these 2 points. All right, so my formula so far is y equals 500x plus c. I'm going to change x and y into whatever x and y here is. So y is going to be 18,000 equals 500 times x, which is 6. And we're going to solve for c now. So 18,000 equals 500 times 6 should be 3,000 plus c. Okay, this is a plus 3,000. Bring it here, becomes minus 3,000. So c should be 15,000. So our formula, okay, for c is going to be 15,000. Y equals 500x plus 15,000. Okay. Any questions with that? There's your rule. Okay. Now remember, what did I do over here? And what is the question asking us to do? Find the rule linking the investment A and time over years. Okay, so the only thing what we need to change here now is we need to change y to A and then t for x. And this is what I mean. You just got to change y, A, which represents investment amount. So your rule is going to look like this. Now, this is more of a year 11 thing. In year 10, we'd like you to be able to do it. So just change y, okay, to amount equals 500 times time plus 15,000. Okay, that's the official rule for his investment. And if I was to ask you guys, okay, oh, actually, before I go there, what this question is saying, what is the y-intercept? Okay, when t equals 0. So what do you think, based on this question, how much did he invest initially? What's the y-intercept? What would the y-intercept be in this formula? 15,000. So that means he started with 15,000. Okay, that's what that means. Y-intercept. So if you get a question like this, especially when you see the word initially, it just means y-intercept. Okay. Now, and this is going back to, if we go to question C, so if I go down, I'll go down later on. How long does it take for him? How long does he need to wait so that his investment will reach? Remember, he wants to reach 20,000. So based on the rule, 500 times time plus 15,000, how long will it take him to reach 20,000? You can use your calculator for this. If you remember recursion, okay, 15,000, okay, is the start. Okay, and you're adding 500 each time. How long does it take him to reach 20,000? So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It'll take him 10 years. Now, I might be going a bit too fast, but I'll go over that again next time because we only have 5 minutes left. Okay, but if you can get to doing A and B in these sorts of worded questions, you'll be getting pretty far already. Okay. All right. If you have to